Okay, let's get started. Today we're going to learn about what's in the next course. It's just exciting. It's the Java EE course, so it's called Java EE Programming. It's going to start in the the spring term. If you're interested in taking it, it's a continuation of this course. For this course, it's not a bad idea to know what's in the future, or what's after this course, which I haven't introduced to you yet, which would be the Enterprise Edition, which is what EE stands for. So what I'm going to do is go through an understanding of the value proposition, or what does EE have to offer versus regular old Java. And there's, about half a dozen or so different utilities that are involved in this. And understanding the big picture in terms of the architecture and the platform and how all the pieces fit together. And then getting a level of exposure, hopefully, to some of the APIs, some of the technologies that are available. You definitely are not going to learn everything there is to know about EE from this lecture. It is an introduction, overview, or an exposure to enterprise application development and what Java has to offer. Very similar to .NET, very similar to Corba, I guess, shared objects, very similar to some of the technologies you might already be familiar with. But this is essentially packaged together, all written in the Java language. So once you learn basic Java skills, you can take the skills and apply it to all of these different technologies. They all work together. So understanding why the Java 2 EE can be used as a platform for development and deployment for web services as well, because most of 99.9, but a lot of application development today is all web enabled. So knowing Java is great because it applies towards not only web development, but it also applies towards mobile phone development. The Android application development is all written in Java. And that's another class I'll also be teaching next spring as well. So everything builds on the base Java that you've had in this class. And it all uses object-oriented techniques as well. Some mix in XML, some mix in HTML, some mix in, servlets and server kind of technologies, but it's all based on the Java programming language. In terms of enterprise computing, what you're looking at is a kind of a list of the not only the challenges but the products, the environment, I should say. So the number one challenge that has always been the case in terms of enterprise computing is cross-platform compatibility. If you're going to build a distributed system across multiple systems, you can't necessarily expect them to all be the same kind of system, like Windows to Windows to Windows. So Java came around to kind of combat that particular problem and add portability, which is why we ended up with that JVM. But now we have middleware such as RMI and some of the other technologies that work sort of like the JVM along with the Java Virtual Machine. They complement the technology to provide a networked type of environment, very similar to a .NET. And if you're familiar with .NET, I keep mentioning it, or I've mentioned it twice already. It is Microsoft owned and Microsoft run, and it is a platform very similar to Java. RMI, I would say. I'd call it more of an RMI/JVM, sort of similar, compatible technology. However, it only works on Windows machines, versions of Windows that have the .NET platform installed. It will not work on a Mac. Will not work on a Unix server. Will not work on non-Microsoft operating systems. So Java's got you have a little edge up when you use Java because it is cross-platform compatibility. So in terms of the challenges, the portability, diverse environments, time to market, well, you learn one language, you use it with all of these different technologies, and here's a small little list of the technologies right in this box in the middle. The key technologies that are associated with this. Packaged together with web services and web capabilities, you're taking a small tool set and making it really pay off for you in the long run. So going back over here in terms of the challenges, integration, assembly, core competence, time to market. These are all some of the considerations that go into make this a strong selling point. And this lecture is not a marketing pitch towards Java EE by no means. It does have its flaws, and I'll mention some of those as well. It is not the end-all of end-all. .NET is still very popular. It's still a growing competing technology platform. And .NET provides the same thing. You can get networking services, communication protocols, all sorts of stuff built into the environment. what we're looking at here, this is what you're familiar with so far in this course, was the SE version, or the JDK, the development kit, or the software, the regular old standard development. The EE stands for Enterprise Environment, or Enterprise Computing. And what I'm going to talk about today is the JMS, the servlets, the JSP, connectors, which is going to be used for JDBS, Java database connectivity. Can't speak today. JDBC, excuse me, that's what I meant to say. XML for our web interface, data binding, XSLT, another complementary protocol used with XML. And then web servers, application servers, components, databases, objects to database tools are all sort of products that work with this. And there's a lot of third-party tools as well that I work with to help you bring the generation up a little bit, turn it into a fourth-generation programming environment a little bit, in terms, especially when we start looking at some of the JDBC components and some of the, that's all written for you. The lines of code is just a few. I mean, I'm making it sound too simple, but it is not that hard compared to traditional style programming. So what is the JEE? Open and standard platform for developing, deploying, and managing. So we have an N-tier kind of concept. So the JVM is great, and the Java SDK, JDK, SE environment is a single standalone computer kind of environment where you write an application for a computer. Or you write an applet, or it's not what I'd call a networked type of environment. So the JEE is the networked tool set. So we have a web enabled either with Apache, and that's what I'm going to actually teach that course with, because Apache is free. There's also a couple of other competing network server components that you can download and use. But I like Apache because it's multi-cross-platform. You can load an Apache server on your Windows box. You can put it on your MacBook. You can put it on a Linux server. It's open source. It's readily available. Been around a long time, and we'll also kind of consider other choices. And you can use whatever you want if you take that course. If you are to end up developing in it, you might want to use what your company is using if you're doing some work at a company that's using a server environment. So it is server-centric, component-based. Enterprise applications are created using it. We do have a micro edition of Java. It is used in Java-enabled portable devices, cell phones. In fact, the BlackBerry is Java-based. The Google phone is Goggle. Android is Java-based. I was going to say Goggle. No, it's not Gaga. Gava. It's a cross between Google and Java. I'm surprised they haven't come up with a new buzzword for Android Java. I don't know. It's the same Java as Java, but it's a small platform. So what you do with that, and you basically use the same Java tools that you use for regular Java programming. As an example, Eclipse is a great environment for that. You install an API for the device, whether it be a mobile phone, whether it be a tablet. It has different APIs. You install the APIs, and you use the APIs for the interface. So you can, actually most of it's written in XML. So you put components together and you compile it just like you compile, and you write the code all in Java using all the same concepts you have, and you deploy it to a mobile phone instead of a computer, essentially, which makes it easy. And then we have the Java Technology Enabled Desktop. We're familiar with that already. The EE works around here. So the Enterprise Edition is the high-end server environment and the workgroup server. Everything this way is the standard. The SE and the Micro Edition are pretty much this end of the field. The green parts, Enterprise Edition and the Standard Edition, have a little bit of an overlap, which is why this line is underneath here, because to do a client server, you have to talk about the client. So the client is part of this picture. So enabled clients have to be able to recognize the server. But really, we're looking at workgroup server. We're looking at server applications, web server enabled programs. Here's the platform. So we got the JVM on the bottom of it, and we have the KVM, which is going to be for small mobile devices, and then the card VM for card technology, Java cards, if you're familiar with that. Java works on everything these days. But over here is what we're looking at in terms of the EE. We have the optional packages that we're installing on top of the Enterprise Edition. Same kind of concept as the standard edition, which we looked at in this class with optional packages. This little realm here in the micro edition, we get a lot fewer smaller components that are more hardware specific as to what it is we're looking at in terms of foundational information for the foundational profiles, for middleware, compatibility. Because what we have here are a lot of services, and we have a lot of third-party people like cellular carriers who are using SMS and voice and data communication protocols. And so the packages are a little bit more specialized in this area. This is as generic as you can get. It works on almost any type of web server. And this, as we've seen so far, is fairly generic as well in terms of what we're looking at. So open and standard solution, which is kind of an interesting observation to make, is that this is all open source, which means you don't have to pay for any of these technologies either, which is great. So using the component and the container concept model, in fact, when we build applications for servers, we build servlets, we're looking at component and container kind of terminology. So it's a model, it's kind of like model view controller is to object orientation. Component and container is the same equivalence to the enterprise edition. It's what we have to consider in terms of the model of the methodology, in terms of the development. So we have a model in which a container provides services, system services, and a well-defined and industry standard. Container could be the Apache server, as an example. Components inside it could be a servlet component, and then we can provide other technologies to work with that. So it's the standard, provides portability of the code because it's based on Java technology, standard-based Java programming APIs. So the value for developers, well, like you are, as I've already said so far, you learn one language, you know it all. But you can use any of the EE implementations for development and deployment. You don't have to use it all. You don't have to install it all. And that's usually one of the issues in terms of the learning curve. When you install it, you don't get anything. And then you have to start installing and adding this and adding that and adding this and adding that. So a lot of it is, a lot of the work in getting the application to run is the configuration of the development environment. Setting the properties of the RMI server, setting the properties of the Apache server, adding things to the servlets to the server environment correctly, configuring the environment. So there's a lot of addition, modification, and customization because you don't have to use everything all in one. So you're picking and choosing. You use a production quality standard implementation, which is free for development and deployment. Uses high-end commercial products themselves that are scalable or fault-tolerant. So it is scalable, by the way. So, which means if you're not using a component, you don't have to install it. You don't have to actually work with it at all. Which, going back and comparing it to the .NET environment, it's kind of the opposite. In .NET, you install Visual Studio, you have everything plus the kitchen sink in there. Not only do you have the .NET platform, which has everything in it, it's a huge memory hog, but you've got ASP in there, Visual Basic in there. You have all these technologies. You're probably not going to use most of them, but you have them configured. But it's like one of those all-in-one, where Java is actually the exact opposite of that. It's nothing, and you just keep adding to get what you want, installing to get what you want, configuring to get what you want. And then once you have it, you don't mess with it. You leave it alone. But see, kind of the opposite feeling, opposite kind of working environment. So a vast amount of the community resources are also available on the internet, books, articles, things of that nature. You can use off-the-shelf third-party business components as well that work with Java. And there's a lot of business components, APIs, tools, interfaces that are Java compatible, that are already built. And those aren't free. You have to pay for those. So vendors work together on specifications, and then they complete implementations themselves, and scalability, performance, reliability, all those sorts of things. You don't have to credit or maintain your own proprietary APIs. You can have them done for you, or you can use third-party APIs. Freedom to innovate while maintaining the portability of applications as well. There's more sales pitch on the application portability. Many implementations. Choices are possible for a variety of different requirements, price, scalability. So there's a large developer pool out there. So let's now that's the sales pitch. So hopefully you're sold on the product so far. let's look at the APIs and the technologies that are included in the EE. Here's a list. So on the top of my head, I said half a dozen or so. It looks like there's maybe a dozen or so. But some of these are blanket categories that kind of overlap. Servlets, JSP, JavaBeans, Enterprise Beans. Let's talk about those a little bit. Connector, Connector J, Java Mail. It's also another competing technology. These are just, in fact, this list grows as well. This is from 1.4 APIs. I'm not sure how outdated that is. It's probably a bit old. I think we're on 1.6 or so. I think we're past the EE5 version. I believe we're on 6, but I'm not sure. Don't quote me on that. The version numbers are different for the EE version than they are for the JDK, or the SE version. So, in terms of what's included in number 5, they're all backward compatible. What's included or what was added on. Some of the more specific protocols for some of the technologies. So let's talk about servlets and Java Server Pages, which is what JSP is, Java Server Pages. JSP is Java's equivalent to ASP. ASP is Microsoft's .NET equivalent. So anything that can be done in ASP can be done in JSP. So it's comparing the two of them again. What's a servlet? Well, Java objects, which extend the functionality of the HTTP server. Dynamic component generation, and a better alternative to CGI, NS API, ISI API, etc. Efficient platform and server independent session management exists, and it's Java-based. Okay, long story short, servlets provide more efficiency for the server. So imagine a CGI, if you're familiar with traditional, let's go back 20 years, when Java wasn't around, and ASP wasn't around, none of this stuff was around. The problem was you loaded up a server, and you can only have so many simultaneous connected clients to that server. If you're familiar, you have to understand client-server technology a little bit to get the point of the story, but when a server loads up and gives something, serves something to the client, in the traditional CGI environment, you could load executable programs, scripts, all sorts of different things in what was called a CGI bin directory. And a client from a web browser could send a request to the server that would go through the CGI gateway. This Common Gateway Interface is what CGI stood for, or still stands for, and it would go into this gateway, protective access to the server, so it wasn't really open to the public, it was a provided gateway. It would go in and run that program and send the results back to the client. And every client who connected to the server who went through that gateway had its own process created because it requested to run a certain program. So at any one moment of time, let's say you have 100 clients connected to this one server. Not bad when the internet's small and nobody's on the internet because nobody knows about it. 100 clients, wow, we're having a good day. That would be a lot of clients. So you have 100 processes running on that server because every client gets their own session, gets their own executable program running and their own results kept separately. Imagine when the internet grew and now we have 100,000 or so, not just 100 clients simultaneously connected. Server can't make it. So what do? Load another server, have another server, have another server to meet the demand of all the clients. Well, that's kind of an inefficient way of doing things. Because why does each client, when they connect to the server and go through the CGI interface, why do they have to start their own program, run their own process? And it eats up server resources. It's like simultaneous users on one computer all running the same program over and over again. So Java came around and said, well, let's create what's called a servlet, which is a small server. But let's only make one instance of all objects. So that's actually what I'm describing, what I'm leading into is the RMI, remote module invocation method. Excuse me, remote method invocation. I can't talk today. Where we have what's called an RMI. We'll create an RMI server. An RMI is a server. Actually, it's a middleware that acts like a server. I'm going to get into the servlets in a few minutes, but I want to talk about RMI because I'm kind of leading into that concept first. So when the client connects to it, they go through, instead of going through the CGI interface, get rid of that completely. This replaces it. We load up, and on the server we have RMI running, as an example. Client connects to the server and asks for the same program, because all these clients are running the same program. Instead of a new process being created for the execution of that program, instead, what ends up happening is the RMI server serves up an object that's already been instantiated, so it creates instances of objects that are alive and running, and serves up the same object to everybody. So instead of creating 100 of those objects, it only creates one. So the same program can be served up to everybody. It doesn't take up as much memory. You only need one server for that. You don't have to load up, 20 different servers to run 20 different processes for 20 different, 200 or so different users. So it made the server more effective, more efficient. It also gave higher level of security to access to those objects and created a more manageable environment. So if you extend the concept out a little bit further, and you have a server and you have servlets, well, what's a servlet? As the name might kind of sound, it's a smaller server. We have servlets give us smaller programs that we load. So we load it up and we create this servlet environment by using Apache, by using a server, because we need a server protocol to facilitate the 80 port entry, to provide a server functionality. Then we load the technologies into the server and we serve up servlets. What are servlets? They're small little Java programs, and they're managed by the servlet environment. So when they come into existence, they can go out of existence. And when you start up the server, we can make an instance of all of those objects so they're ready to go. So in the old days, when the user was in their HTML browser and they went to the CGI gateway and they requested, that's slow. Connecting to a server, you're going to the directory, you're running an executable program, the program's running on the server, it's getting the results, it's sending it back with some HTML code to the user. Slow. Very slow. Not only slow, but it eats up the resources of the server. So servlets basically make it run faster. So the servlets load up at the beginning, you start the server, instances of all these objects are ready to go. So the user connects, client connects, goes into the Apache server. Here you go, here you go, here you go. It's already run, it's already executed, it's already got the results for you. It refreshes, and there you go. All it does is serve up utility, serve up functionality. What's the functionality? They're little programs that you write to do stuff, to connect to the database, to run a query, to do server, anything that you could have done through CGI, you can do application-wise through any type of servlet environment. So dynamic contents are generated. So we have dynamic content generation. We have information that we can serve up for session data. We can have information served up for execution of programs, scripts, anything. It's efficient. We only have one copy of each one of them. And then we can create what's called beans, which are runnable programs, kind of like, sort of like applets but on a server. Runnable program code that works with the servlets. And it does nothing more than functionality. It creates, it's all written in Java, so it creates connectivity between components. It creates executable code, functionality, stuff like that. And I'll talk about beans in a few more minutes, but I'm just kind of getting at the servlet concept. Alternatives, much better than CGI, 100% better for those for efficiency. When number one, it's ready to go when you connect. There's nothing to run on the server anymore. Server's already run it, managed it, has it ready, serves it up. Platform and server independent. So you don't have to have a special configuration for CGI like in the old days, or any of these other technologies that were server. These were server specific. It can run on any server that runs any open source server package that's compatible. We also have what's called session management, so no need for cookies anymore. No need for information to be passing back and forth. So we can have sessions controlled. So you logged on to wellsfargo.com and you went into the server. and you authenticated, you can keep track of what you did. When you come back, you'll say, hey, you know what? You didn't do this. You didn't finish. Would you like to start off where you left off? You can keep track of, through session management, what all the clients are doing much more efficiently and much more reliably without having to write anything to the client's computer. So there's no cookie being written. There's no relying upon anything from a client. It's all managed on the server. And if you study client-server technology, you know, security is on the server, not on the client. You don't want that client to do anything. Now, with the new mobile devices, tablets, and things, we have our clients are being put on diets, as I say. You know, in the old days we had really thin clients, and then they got fat, and then they got thin again. So they were really thin back in the beginning of client-server computing when we had, and thin I'm talking about in terms of the client technology. We had a monitor and a keyboard. That's thin. There's no hard drive. There's nothing. There's a network card. Those were terminals in the beginning. And then we got fat. People got notebook computers with 300 gigabyte hard drives. Huge. I mean, they were like desktop replacements. Those are fat clients. They're fat because they have so much memory and so much stuff, and they can do a lot more. They're more powerful. They're more storage and stuff. And now we've gotten thin again. Tablets and mobile phones. You know, you don't want to have to rely upon a fat client. So you put everything on the server, which means you have to have a fat server. you have to have a lot of technology installed on the server to support any kind of client today. So an app on a mobile phone or on a tablet is going to work the same as on your computer, which means you got to target towards a thin environment. So it's all Java based as well. So Java server pages, JSP technology, and this is just the generic servlet technology that I've been talking about so far. It comes in a lot of different shapes and sizes. As I mentioned, RMI can be considered part of the concept, but RMI is sort of a different animal in itself, not to confuse that. But JSP is the ASP equivalent, and it does nothing more than serve up, so enables separation of the business logic from the presentation. So in a Java server page, you have an HTML interface, because everything on the internet through HTTP interface or a web browser is HTML marked up based. So JSP works with HTML. Presentation is in the form of HTML or XML or XSSLT, which is a lower version, well, a more specific. So XML is a language definition. So you don't have to know anything about HTML or XML. Most people know HTML if they've taken a web programming course. And you know XML, if you've done any, it's a markup language very similar to HTML, but it's for data. So if you've done any XML interfaces that you were transferring data from the client to the server, it was in an XML. It's a tagging system just like HTML, but it's for sending and tagging data, first name, last name, serial number, versus bold, underline, hyperlink. You're just marking it up to say it's a piece of data. So we have business logic that's implemented in JavaBeans or custom tags. So the JSP, which is a text file with a JSP extension on it, that's written, it's uploaded to the server, and it's run on the server, not run on the client machine. You can use a JavaBean as an example, or any type of custom tag associated with it. Call somebody and say, hey, do this for me, do that for me, do this for me, all on the server end. And the bean might work with a servlet somehow to connect to that database and get all the records for this user, print them over here. Okay, print out an invoice, go to the shopping cart, do all sorts of different functionality. They're little worker beans. And they call them beans because they're small. They're small little programs, so that are maintainable. It's modularized. It's also reusable. So if you pull the technology out, which is kind of another interesting phenomenon that existed, if you pull the technology out and you build a repository of these beans, you just keep reusing stuff. You don't have to reinvent the wheel, you just share cross development in terms of the applications. Extendable via custom tags, builds on the servlet technology, JSP. So let's talk about JavaBeans, Enterprise JavaBeans, EJB. Server-side component technology. Consider it just like an exe file, actually. It's just like a .class file that you create and you put on the server. easy deployment, development of Java technology based on applications that are transactional, and it's performing some sort of a transaction, distributed, multi-tiered, portable, scalable, secure. They're just little programs. It's a fancy word for a little program that sits on the server that performs some activity on request, usually through a JSP interface. They leverage the benefits for component level on the server side, separates the business logic from the system code, container provides system services, provides a framework for portable components, or works with all of the EE compliant servers over different operational environments, and enables deployment time configuration. That's another interesting phenomena. We're looking at, instead of a static environment, which we have in a CGI interface, if you have an executable out there, you replace the executable and you restart the server. We're looking at a more dynamic deployment with using Java EE, actually. It's more real-time responsive. We can actually adapt and change things while the server is actually running. Some things do require a server reset for some of the servlet technologies, but we are looking at deployment time configuration versus a compile time configuration type of model. Here's kind of a picture that puts all the pieces together in terms of the architecture. We have the server here. In the server we have the home and the objects themselves, the enterprise beans component. So we have a component that manages the beans, and these are beans that the client might use. So these are kind of beans that lead into this manager of the beans that work with, let's say, a database component in this example. This database might be on a different server. It might be on a different computer completely, might be part of the same server. The interesting thing is, because it's broken out into pieces, we can put all of this stuff on different computers, on different servers. So instead of having, in the old CGI days, 100 of the same computer, of the same server, what we do is what we create is a distributed environment. We take a dozen or so servers, or however much we need, probably 2 or 3 servers, I should say. Make one a web server, make one an application server, make one a database server, and kind of dedicate the servers. And then we can swap the servers out. We can move over to a replicated database server, or swap out the application server, or make multiple application servers, or multiple web servers, which creates what they're calling the N tier, or it's multi-tiered server environment, which Java allows you to do. So the architecture itself, the EE architecture, lends itself to the tiering. So we can employ different web server technology on the web server, different on the application if we want. The database can be totally separated out as well. We have different interfaces, remote interfaces, home interfaces, sorts of different things. And here's kind of like how the Java Bean works with all of this. So we have the enterprise Java Bean here at the top, and we have session communication, synchronous communication and asynchronous communication going on through states and stateless type of situations, where we have a manager, container manager, we have a bean manager. The managers are nothing more than a way of describing the configuration of these components and how they're residing on the servers. The servers have managers, as I mentioned before when I was talking about RMI. The manager keeps track of how many beans are created, which ones does their own garbage collection, which ones are still being accessed, which ones are being used, which are, and can serve up the beans essentially as an on-needed kind of basis. Keeps track of the environment in terms of security, keeps track of garbage collection, as I mentioned, all sorts of different things. So the bean managed persistent entity bean can be used to keep track of something. The session bean can be used to keep track of the session data for each one of the client connections, perhaps. And the theory here, what you're supposed to be getting out of this is it's like all divided out into separate different components. So you use the enterprise Java Beans to kind of dissect the big picture out and delegate responsibility to different objects. And it really does lend itself to a true object-oriented server environment. Because as we studied object orientation in this class, we want self-identifiable single identity objects that are only responsible for one task. And if we break it out and we want to extend that object-oriented methodology to the server, that's what we're doing with those beans. We're keeping each one of them separated out into its own unique identity to make it kind of a special bean object. Java Message Service, JMS. So this is another interesting technology that comes with the EE version of it. Messaging system, MOM, provided. So we have the messaging component, decoupled communication, asynchronous communication, plays a role of centralized post office. It's a communication platform to facilitate intercomponent communication through message exchange. It's kind of equivalent to, when you take a Unix course and they teach you about processes and mutexes and semaphores and all of the different, mailbox controlled inter-process communication protocols and things that you get on a Linux server. This is the JMS as it applies to Java. Keeps track of process communication, message exchange, message information between components. Benefits from the messaging system: flexible, reliable, scalable communication. Point-to-point, publish and subscribe. So JMS defines the standard Java APIs to the messaging system. So we can create inter-component communication through JMS. And we'll look at JMS in the EE course as well. Connector architecture. So connector architecture, heavily used today because this is where we get third-party control. We can connect. We can have connectors for databases, for PeopleSoft, for SAP, for all sorts of different components. So it defines the standard APIs for integrating technologies with EIS systems, enterprise information systems, such as SAP and PeopleSoft. SAP is actually kind of the growing technology today. PeopleSoft, not so much. SAP, I think, has more popularity right now. And you can get SAP certified at ITU. Take 3 classes, and I think you have to take a test or something, don't you? We're authorized to actually do the certifications, so the classes qualify. But that's more of the working with the business logic. I wouldn't call those technical courses. I would call them, but believe it or not, there's a lot of jobs in SAP right now, so it's not a bad area to get into, actually, as a side note. Before the connector connectors existed, each app server has to provide its own proprietary adapter for the EIS system. So you had different adapters, different protocols, different techniques for connecting between the different systems. Connector provided one solid foundation, one API in Java written. You just apply the connector you want. It's all done the same way. There's 5 or 6 different steps at the most, and voila, you have a connection. So the EE aimed at simplifying the connector technology to make it more standard, more cross-connector compatible, and took away and provided more support, took away the responsibility of the connector on the EIS provider, gave it, made a more shared environment with the Java engine. So with connector architecture, the same adapter works with all of the Java 2E component containers. So one connector works with everything. The problem before the architecture, we had application server 1, 2, 3, 4, many of these with any number of these, and we had all different connector objects, or I shouldn't call them connectors, all different interface APIs that were needed. They can all just make one. So essentially take it away, build it into one connector part, which makes JDBC extremely easy. So JDBC, it's Java database, which I haven't gotten there yet. Connectivity is probably the last topic. And the connector object for that is really nice, actually, because it connects to Oracle, MySQL, everything. And you use a different connector depending upon the database you're connecting to. But you just change the connector and you add a different database, and it all works the same. The application will work identically, given the same tables and stuff. So let's take a moment here and look at the Java authentication and authentication services. So authorization and authentication. So security, aka security. So how do you authenticate? So pluggable authentication framework. User ID, password, smart cards. Used in small devices for biometric, verbose, all sorts of different types of components that are used in terms of validating users and clients. So application portability, regardless of the authentication scheme that's underneath it, provides the scheme independent of the API, so it provides the facility to build authentication in without having to worry about it as an afterthought. So authentication schemes are specific login configuration files. They're read by the JAAS and they're interpreted. So here's an example of using a biometric, a smart card, some sort of an authenticator device with a login module and SPI going through the logical API going through the application, and then exterior to this we have a configuration where we configure it to be used with any type of device that's coming in, and it provides again the same thing that the connector logic provides. It's kind of a built-in standard authentication platform utility API that's used, that's controlled by Java, and it's all run together in the Java API environment that controls your authentication essentially. So it really does streamline that kind of terminology, that technology as well. So in terms of some of the other APIs and technologies, Java naming and directory interface is also a component of it, utilizing applications to locate resources, objects in a portable fashion. So JNDI is used for the distributed computing environment, facilitates a way of a naming convention, naming directory interface. So applications use symbolic names to find object references. So you can locate it anywhere you want, you use a symbolic name, and you create the symbolic links to the naming and directory system, and then everything's accessible. Well, as long as it's up and running. So if the server goes down, you can't, well, unless you have a backup, you can't make it accessible. But in terms of name resolution, finding things, symbolic links. So symbolic names and object references, configured by the system administrator when the application is deployed, creates that environment for you. There's the JDBC I keep talking about. And we'll look at, one of the projects will be a JDBC project actually, because every internet application out there uses a database. You can't create an application today without a database connectivity. It's just the de facto standard these days. So JDBC ends up being used a lot. So it provides the standard Java programming API for relational databases. It also works with object-oriented databases. It uses SQL as an interface. In fact, it takes and will actually execute SQL statements and work really nicely with the result sets that come back as well. So it kind of automates the entire connectivity. Vendors provide the drivers, the JDBC compliant drivers or connector drivers. They get loaded on, and then voila, you have connectivity. And it's as easy as writing maybe 1 or 2 lines of code. You've connected and you've logged on and you've retrieved the information you wanted. So it kind of streamlines the entire process. In terms of the management component, management applications should be able to discover and interpret the managed data from any of the EE platform components. So the EE environment has configuration for management. Management kind of gets broken out into a couple of different categories depending upon what you're focusing on. So simple management platform can manage multiple servers from different vendors, multiple different technologies as well, protocols to ensure uniform SNMP, WebBeam, other management station leverages JMX, which is another kind of competing supplemental technology that can be added on. So in terms of the tools in the deployment, and going back to here, this is more of the configuration and the usage that comes standard that has to be part of the configuration. It's the only way I can describe it, or the installation, I should say, of the server environment, is to set the management correctly. Log files, protocols, messages, warnings, quotas, all sorts of different things that can be set with that. In terms of deployment, the tools are pretty standard. The platforms are pretty wide open in terms of flexibility. We have standard development API that's pretty universal. So we take the IDEs, the vendor deployed tools, the management tools, and we can deploy it out on different platforms essentially. So standard universal remote. So I like this kind of, there's no remote control API. I like this kind of reference because it's sort of the universal remote. You know, you just press a button and it goes to a different J2EE platform. You press the button and it'll go to the web server. Press the button and it'll go to the distributed environment or something, an RMI server or something. JMX, a single technology for the J2EE platform. So we have the API over here. The application, so here's the application server, the dynamic component or the dynamic deployment is what the JMX is, the de facto kind of standard that works with the application that allows us the connectivity through the management. So the manager, the Java EE manager is going to keep track of connectivity through application level application services that are provided from an application server as it's configured. So the end-to-end architecture. So let's talk about the N-tier environment for a few minutes. I've mentioned it already. Here's the client-side presentation. So if you think about the tiering, this is where it kind of gets interesting because we can have multiple EE configurations going on. Obviously we can get rid of all this and put it all on one server. And for purposes of this course, you'll probably be running your client and your server together. For purposes of this course, purposes of the next course, I should say. You can load it all on the same computer, run it from any computer, essentially. However, that's not real life. So a business, a real life company, who's not learning, who's deploying, is going to do something like this. So we have a web tier, a JavaBeans tier, an application tier, an application or an enterprise information system tier, excuse me. So the client presentation here, start at one end here. The browser, we have Java applets that might work on the, obviously, Java applets are going away though, I have to tell you. So, and JavaScript is not really part of Java. I wouldn't consider it the same technology. It's a scripting language for the app, for the browser technology, but I wouldn't call it. JavaScript is not part of any Java anything. The only thing in common is the name. The technology is completely unrelated. So a lot of people have the confusion thinking that JavaScript is part of Java. Nah. No. Pure HTML applets. On the desktop we have a Java application. Those are the things you've been developing in this course. Other devices, maybe another client, a cell phone, a tablet or something that might be connecting. That might have a client code, the JVM loaded on it, the virtual machine loaded on it, essentially. That can go to the server and run something. So the server-side presentation is generally on what's referred to as the web server. And the web server is doing nothing more than serving up the portal, the web services that are separated from the business logic or the application. This would, I guess, would be more of the application level versus the database level. But here the web server is going to have your JSP technology on it, your Java servlet technology, your platform, anything that's going to be specific towards the web. And this is just nothing more than providing the entryway or the host. So your security is going to be on here as well, major security. And then you're going to load another server into this picture. And it's going to be business logic, or it's going to be, instead of presentation or web enabled, it's application enabled. So most of the processing power of the server is going to be dedicated towards running the JavaBeans. So the Java Enterprise Beans are going to be sitting here, and the Java Enterprise Beans, think of them as worker bees. It's because a lot of people wonder, well, why do we need beans? If you're not going to give access to the application, so if we wanted to get rid of these beans, because we don't need to program with beans if we don't want to, right? Then we're going to put the application here. If you're going to put the application out here, you're putting it very, very, very close. If you move this layer out this way, you're putting it very, very close to the web server. And not only that, but you're not controlling any of the access to the applications. So the closer you get it to the client, the more vulnerable it is, the more exposed it is, the slower it's going to run, because you're going to have clients accessing it directly. If you control it through the JavaBeans, then you've got a few beans running on a server, on a logic server, and they can only access these stuff out here that they're allowed to access. So it's the bean accessing the information system, not the web server. Makes it more secure. In terms of tiering, you're going to have multiple servers to begin with. Instead of loading everything on each one of the servers and duplicating all the servers, you put on fewer numbers of servers because you don't need as many. And you separate out the logic that's being performed on each one of the servers, and you use the beans to connect it. So beans are really connector objects. I hate to use the word connector. They're small little programs that go run out to this database, do something, run out to this program and do something, run out to here. And then this is on the back. This is what's referred to as the back end. The web server is the front end. This is the middle tier. It's middle end because it's going to ride between the front and the back end, and it's going to have one connection to the server end, to the web server, and multiple connections to the back end. And this is what we're going to have in-house. This is on the intranet. This is on the internet, and this is in the middle. This is providing the connection to the gateway. So, creating a fortress eventually here. So, you can't break through that fortress because those beans are only going to do what the beans are supposed to do. And we have a manager on here that's keeping track of the bean activity. So, it's control, it's tiering. So it's done for efficiency, for security, for modularization, for adaptability, for expandability, for maintainability. So it makes it easier if you break it all out as well. So there's a lot of different reasons for tiering, I should say. And of course, your small business is going to stick it all on one computer, but you can still tier it on one computer. However, you can still use beans, you can still use a web server, but it's all located on the same system. So you just break through the security, and you're there. You have everything. So, in terms of the components and the container architecture, what we're looking at are how we're going to house everything together. So the JavaBeans container, the web container, the applet container, the app client container are all different container components, containers that contain components. So the web server. The web server, and here's where RMI kind of fits in, actually. Let's say we have a database out here, and here's our database. We can get at the database through many different component interfaces through containers. So if we separate everything into containers, then we have 1, 2, 3 access points into that database instead of 2 million or so. So from the enterprise bean containers, it's probably the most secure way of doing it. We have a JDBC component that the bean is going to, essentially from that bean tier, it's going to go over here and run the JDBC driver, connect to the database. From some of the other services that might be also used from the bean perspective. From the web container perspective, we're looking at two technology. We're looking at JSP and we're looking at servlets, as I mentioned before. So we're going to load on the servlet, create the JSP functionality through JSP pages, and provide that through the web server and stick all that stuff on the web server. From the client side, we got our applet container. It's going to serve up applets to clients through HTTP interface. What we're looking at here is an RMI interface that might exist between the web container and, let's say, the enterprise bean container. And let's say it's also going from the container here, from the client container, from any type of generic client interface, so client connection. So this is why I always refer to RMI as remote module invocation, excuse me. But it's more along the lines of the middleware that's holding all the pieces together. So the RMI engine in this particular case is providing the connectivity between the layers. And the RMI manager, that's the manager that's keeping track of performing the security, the authentication, the, if an instance of this bean is already created, then register it. And if it's registered, well, then use it and use it again and again and again. Don't create another instance of that bean. So only one thing of each one of the objects is created. Only one connectivity method exists. So the RMI is sort of the glue that's being, and we'll look at RMI extensively actually in the next course. And it's the glue that's holding the tiers together in terms of the technologies, which is where that kind of fits into the picture. So in terms of the containers, what they handle, containers are going to have the concurrency control, the security, how many people can access a particular object simultaneously, what can that bean access, what's it allowed to access. Availability, scalability, persistence, you know, when are you going to refresh it, transaction control, transaction management, life cycle management, all sorts of different management. From the component level, we're looking at the presentation of the content from components. So, and the business logic that we're going to build. So components go inside of the containers. The containers are uniquely defined in terms of their purpose, how they fit into the big picture, and these generally are representing the tiers. So going back to this picture here, these are going to be our component levels that are tiered, and the RMI is keeping it all together. Is where that's fitting into the picture. So containers and components, to finish this out. Containers do their work invisibly. No complicated APIs. They control. They're controlled by interposition, but the positioning where they fit into the big picture. Containers implement the J2EE. You know, they look the same to components. Vendors make the containers. Great freedom to innovate, to change things around and stuff like that. Application Anatomies. I can't say that word. Possible application configurations, let's call it that, or application settings. Anatomies, whatever. Okay, so here we go. This is actually what I've been describing, and this is putting the pieces together in terms of the last three pictures I keep going back to, or last two pictures I keep going back to. We have our web server. Our web server is going to have our JSP or servlets on it, and our servlets are going to connect to our JavaBeans server. So our enterprise JavaBeans servers are going to be here. Our JavaBean worker bees are going to be going back and forth. And then they're going back and forth, and these look like databases in the executive or the information systems, enterprise information systems that are out here. And think of these as applications. This is the accounting program, the marketing program, the Salesforce program, or whatever happens to be on here. And we have this intercommunication that goes on along between in-house standalone. So here's where the connectivity really does actually kind of make a lot of configuration sense. We have two portals into this. We have the client portal from the web browser, from a traditional, entry point from an HTTP protocol, web, internet, and then we have the local, in-house. You're on-site connectivity. You're in a retail store. You're in a corporate headquarters. Standalone connectivity, entry point. All going through the same system, which is interesting. All going through the web server that's being accessed. Or if you're inside, you don't need to necessarily go through the web server. You're going to go through the standalone. You're going to go through the enterprise bean server entry point. The bean point, though, is what's controlling the access to the applications. So you're using the same protocol logic. You're using the same configuration, the same security inside of the company as you're using outside of the company, which is kind of interesting because you're killing two birds with one stone. You're web-enabled, and you're also company-enabled. So your business is being run correctly from a local user perspective, from a functionality, from a corporate environment, same as the web environment. So you don't have take the data here, transport it to here, which is what we had in the old days, actually. Your web server was different from your application server that you were using inside the corporate. Your applications, your accounting program, everything that was internal to the company was under lock and key, and because it wasn't safe to be put out on the internet. And it was like a separate, different set of programs than the programs that you were using for your customers or for your field service people, and there was no connectivity between the two. So what the Enterprise Edition actually does is sort of creates one platform for all. It makes it universal. So the same service, the same protocol, the same security, the same databases, the same applications are used no matter how you're accessing it through the web interface or through the standalone, through the local interface, which simplifies the connectivity and makes everything universal and makes everything the same. So it really truly bridges the gap between the outside world and the inside world. So we're no longer considering web development as an example. There's no such thing as web development here. If it's all, and we have a web server, the web servers are web development, but everything else here is regular old in-house development, web or not web. Doesn't really matter. Depends on how you're getting at it, what portal you're coming through. So 4-tier J2EE applications exist with HTML clients that go through JSP servlets and that use JavaBeans that go through JDBC and connector. We'll be creating in the Java EE course, if you take that course, this is what we're going to be actually working a lot with. Using these technologies together to create this 4-tier type of application. The 3-tier, also usable with taking out the connector object and just going from an HTML client to a JSP servlet environment to a JDBC. And believe it or not, Eclipse and NetBeans provides a really nice interface to all of these technologies, which would be the development tool of choice. In terms of a 3-tier, you can have a standalone enterprise JavaBeans standalone application that connects, and this would be on the server, on the application server. And then a B2B kind of enterprise application when it exists, in terms of going through JMS, the messaging service, or through XML-based messages going back and forth, sending and receiving information between application to application. XML is very helpful for a B2B type of environment because you could take this and go B2B connectivity through XML, which is pretty nice in terms of transporting data back and forth. So, let's say, for example, a rental car company who has a rental car database out here and a JavaBeans server, and how many airports are there in the world? Millions. But they can go through the same enterprise or Hertz rental car portal. It makes it so other people can sell products and services outside of this company environment, but they have a connectivity in, so you don't rent the same car twice or something. Keep track of it, do automatic billing, stuff like that. So which one to use depends on several different factors. After looking at all of the different varieties, and that's pretty much it. That's what the EE environment contains. What to use depends on the application that you're developing, requirements for the application, availability of the tier itself, availability of developer resources, how many servers you have. If you're a small startup company, you can still use all of those components, stick it all on the same server. Or maybe, invest in 2 different types of servers, build multiple servers to work together with that and tier it a little bit more. The more you tier it, the more fault tolerant you get, the more flexible you get, the more location specific you don't have to be. You can spread things out a little bit. So depends on the environment. So we'll take a look a little bit about that towards the end of the course. But the course is really going to focus on the technologies and all of the different things. So, and believe it or not, it's easier than this course. This course was on learning object-oriented programming, inheritance, stuff like that. This is all terminology. It's extremely easy to implement, actually. It's much easier to configure RMI or JDBC, and much easier to configure even, I have to say the JSP is a little tricky. It's more like if you don't like web development, you're not going to like JSP, but it's actually easier than writing HTML code, I should say. But not hard, it's just a little, and I think the worst part, actually, I'd say, it's a little hard to configure sometimes. Honestly, that the biggest problem is configuring your development environment, is getting all of the components to work correctly and to refresh and to load your latest changes and stuff like that. That's the most difficult part, and just to say, most challenging part. So I'll leave you with that next week, and this was the last lecture for the Java Object-Oriented Programming in Java course, so the very last lecture. And so next week we have final exam review, which you've all been waiting for. I actually wrote the final already. I was going to give you programming questions, and then I got nice. Instead, I'm giving you 25 multiple choice questions. It will be different than the weekend exam that some of you may have already taken. If you've already taken the weekend exam, you don't have to take this exam. This exam is actually a little bit harder because it's spanning a lot more subjects. The weekend exam, I cut it like maybe halfway through the course or so because that class was so short. It ended before October started, so it was very intense in a very short amount of time. So that final was a little bit easier than it probably should have been. If you've already taken it, however, you're done with that. If you haven't taken it, then on December 12th or December 14th from 10 o'clock in the morning until 4 o'clock in the afternoon, you should show up here and take the final exam. And the final exam will be 25 multiple choice questions. And on next week, if you've already taken the exam, you don't have to show up next week. and next week, if you haven't taken the exam and you want to know what's on it, I'll be telling you, I'll have the exam in front of me, and I'll tell you what subject matters to study and what to know so you can ace the exam. How's that? Questions? Yes? Only multiple choice, 25 multiple choice questions. No. But the questions are harder, no programming. The questions are harder than the weekend one, so. If you took, did you take the weekend one yet? No, you didn't take it. Oh, okay. So I promise you, before I was telling all the weekend people that they waited, they're going to have to write programming stuff. And then I decided I wasn't going to torture you guys with having to write source code, because that's just problematic. Problematic for grading, problematic for reading your writing, problematic for a lot of different reasons. So I went with a multiple choice variety. But I covered practically everything possible in the course. So it's a lot more, the final for the weekday is a lot more extensive than the weekend one ended up being. The weekend one, did anyone in here take the weekend one? No, none of you did? I offered it up like a month ago for those people who showed up, but for that section of the course. But I had a good turnout. I had like maybe about 30 or so from the weekday when I went and took it. Because I said, and it was easier. I said it was going to be easier. So. But yeah, take it like a month or 2 months or 3 months before that, before December, you know. So it was like a long time ago. It was a couple months ago. So anyway, long story short, it's still going to be fair. It's still nice. It's not too hard, but it's just slightly harder than the weekday one. It's all multiple choice. How hard can that be? Okay, we are done for today. Oh, another question? You can take from, if you show up at 10 o'clock in the morning, you can take till 4 o'clock in the afternoon. You're not going to need it, though. You're only going to need maybe 2 hours. I would, if you're flying in or if you're coming in between work on your lunch hour or something, allot 2 hours just to be safe. You probably will only take an hour, hour and a half, but who knows? So 2 hours. And plan that we probably won't be here between 12 and 1. Or actually, we probably will be. On the weekend, we took lunch break, but I don't know. We'll put a sign on the door. I think, you know what? I think this time we could probably work all the way through it. There probably won't be a lunch break time. So you can probably take it at noon. Because we'll have more staffing during the week. So we'll get more TAs in here. How's that? And then we'll have people watch the room at noon. Any other good questions? No? Okay, we're done. Have a good one. See you next week.